So in section 5 of unit 1, we're going to talk about solving quadratic equations. But before we do that, let's just have a warm-up, a couple of warm-up questions. One is a straight review of what we did last time with working with radicals and simplifying radicals in this case. So negative 10 plus root 50 over 5, how can we simplify that? Well, the root 50 or 50 can be broken down to 25 times 2 over 5. So here we get minus 10 plus 5 root 2 over 5. And since both terms on the top of the numerator can be divisible by 5, this simplifies to minus 2 plus root 2. The next question, so more like a review from grade 10. Has nothing to do with simplifying radicals in this sense. But here we want to find the roots of the equation. Root 3x minus 1 is equal to x minus 3. So again, finding the roots is really solving for the equation. Solving for the value of x or finding the value of x that makes that equation true. So the trick here is because we have the square root of 3x minus 11, not sure what to do with that, we actually square both sides. So this takes advantage of the property that if we have root x squared, that's equal to x. And so in this case, when we square root 3x minus 11 and square it, we just get 3x minus 11. And on this side, since we have to square x minus 3 quantity squared, we do expand that. So it's x squared minus 6x plus 9. And solving a quadratic equation, really we have to get one side equal to 0. So we're going to subtract 3x and add 11 to both sides. So subtract 3x and add 11 to both sides. So I get 0 is equal to x squared. Well, minus 6x minus 3x is a minus 9x. And 9 plus 11 is a 20, plus 20. So here we can use the quadratic formula, or hopefully we could factor this, and it looks like it's factorable. So here the product is 20, the sum is minus 9, and I see the integers are negative 4 and negative 5. So this factors too. So I'll go through the steps of decomposition, but there's something that we really need to know and understand for grade 11 to make our factoring faster, is that if our coefficient to x squared is just 1, we could actually just plug in the values negative 4, negative 5. In other words, this would factor to x minus 4, x minus 5. But I'm going to show through decomposition that we're going to actually get the same thing. So that's what decomposing means, is that here we want to take the negative 9 and break it down to the two integers that we found. So this is going to be, then we need to factor each of our pairs, if you want to call it that. So I'm going to factor x out of that, I get x minus 4, and I'm going to factor out a minus 5 out of the next pair, and that's going to be, it leaves me x minus 4. So here we have a common factor of x minus 4, so I factor that out, and we're left with x minus 5, and we can see that just what I said, we could kind of shortcut this at the very end. So therefore, well, let me do this completely. This is equal to 0, so this implies that x minus 4 is equal to 0, or x minus 5 is equal to 0. So here x is equal to 4, and x is equal to 5. Therefore, the roots are 4 and 5. So really today, or this unit is nothing new. This is a complete review of grade 10 in terms of solving quadratic equations, and I'll go through various examples of various methods and how to do this. So here we could use factoring, which I just did above. You could actually solve by completing the square if it's possible, if it's convenient. And finally, to me, the last resort is the quadratic formula. I believe in grade 10 that you guys also talked about the discriminant, and from there we determine the number of solutions using the discriminant. And finally, we're going to be able to solve problems using quadratic equations from real-world applications. We'll review this, or we'll go this into more detail in 1.8, where we spend some time solely looking at word problems. So let's go through a particular equation. So here we're given 3x squared plus 10x is equal to 8. So we're going to solve this in a couple of ways, or a few ways. So here we're talking about factoring. So this is very similar to what we just did above. We need one side equal to 0. So I'm going to subtract 8 from both sides. So you get 3x squared plus 10x minus 8 is equal to 0. So here do PSI, product sum integer. So the product is negative 24. Needs to add up to a positive 10. So the integers here are going to be 12 and minus 2. So I need to break the plus 10x up. So we get 3x squared plus 12x minus 2x minus 8 is equal to 0. So really important to note, just gave based on the shortcut I gave above, we cannot use this shortcut here because we have a 3. So we actually have to go through the process of decomposition. So take that pair, take out the GCF out of that, we get 3x, we get x plus 4. And on the next pair, we factor out negative 2, and then we get x plus 4 is equal to 0. So we factor out the common factor of x plus 4, and we're left with 3x minus 2. So therefore, this implies, and I'll carry this over here, this implies that x plus 4 is equal to 0, or 3x minus 2 is equal to 0. So solving for these two little equations, we get x is minus 4, and then here we get 3x is equal to 2, dividing both sides by 3, we get x is equal to 2/3. So therefore, x is equal to 4, or 2/3. Those are my two solutions. Another way we could do this is actually completing the square, which makes this, depending on how nice it can work, it's a little bit more challenging, or depending on if it can work out nicely, it's actually a little bit easier than factoring or the quadratic formula. So in this one, it's actually not going to work out the best, only because it's going to be hard to complete the square on this one. So let me rewrite the equation. And I'm going to put some space into here, because what we want to do in completing the square is we want to leave the 8 on the right hand side. And what we want to do is we want to add and subtract, again, something that makes this a perfect square trinomial. So again, the formula to do that, the algorithm to do that is, first I'm going to factor out a 3. So I'm left with 10 over 3x. And sort of the algorithm to do that is I need to do 10 over 3, divide that by 2, which is 5 over 3, and then I need to square that, which is 25 over 9. So I need to add 25 over 9 and subtract 25 over 9 to the equation. And again, the whole purpose of doing that is that trinomial, there's a perfect square trinomial, and that becomes x plus 5 over 3 quantity squared. So this is why I like doing the work on this side, because this plugs in to over here. And then the minus 25 over 9 still sits on the outside. And that's equal to 8. And notice that I left the 8 on the right hand side, because eventually we want to have our perfect square trinomial just on the left. But bringing over the left, or subtracting it to both sides, making it equal to 0, will actually complicate things. So here I'm going to distribute the 3. And that makes 25 over 9, so that reduces to be 25 over 3 is equal to 8. So what I want to do now is add 25 to 3 to both sides. I want to add 25 over 3 to both sides. So here I need to make a common denominator of 3. So that's going to be 24 over 3 plus 25 over 3. So let's continue over there. So I get 3x plus 5 over 3 quantity squared is equal to 49 over 3. And then I want to divide both sides by 3. So I get x plus 5 over 3 quantity squared is equal to 49 over 9. Now this is why we want the perfect square trinomial alone by this side, because now that we have it in factored form, I could take the square root of both sides. So I get x plus 5 over 3. And remember, when we take the square root of both sides, we get a positive and negative answer. So square root of 49 is 7, and the square root of 9 is 3. So here we get x plus 5 over 3 is equal to 7 over 3, or x plus 5 over 3, got the 5 over 3 here, is equal to negative 7 over 3. So in this case, we're going to subtract 5 over 3 from both sides. So we get x is equal to 2/3. And on this side, we got x. We're going to subtract 5 over 3 from both sides. So minus 7 over 3 minus 5 over 3 is equal to minus 12 over 3, which is minus 4. And notice that this was the same answer, I forgot the negative over here, that we got when we factored negative 4 and 2/3. So a little bit longer process. If we complete the score a little bit easier, in other words, that when we factor out the a value and then new b value is divisible by 2, it goes through a little bit quicker. The last method we learned last year to solve a quadratic equation was quadratic formula. So quadratic formula again was x is equal to minus b, write that bigger, minus b plus or minus the square root of b squared minus 4ac all over 2a. So we do have to get one side equal to 0. So we'll just subtract a from both sides, so we get the same equation as we did up here. So 3x squared plus 10x minus 8. 3x squared plus 10x minus 8. And so here my a value is 3, my b value is 10, and my c value is minus 8. I don't like the quadratic formula that much because we need to be really careful in replacing or substituting our ABCs in, and then taking extra care with our arithmetic in that formula. So x is equal to, so minus b, so minus 10 plus or minus the square root of b squared, which is 10 squared, minus 4 minus 3 times minus 8. So you got to be careful not to forget the negative there, all over 2 times 3. So this is going to be minus 10 plus or minus the square root of 100, minus 4 times 3 times 8. So that's going to be 24 times 3, which is 96. So it's going to be a positive 96. Over 6, minus 10 plus or minus the square root of 196 over 6. So the square root of 196 is actually works out to be perfectly as 14 over 6. So x is equal to minus 10 plus 14 over 6, or minus 10 minus 14 over 6. So I've already worked on each of these. This is going to be minus 10 plus 4 is 4 over 6, which is 2/3. And in this case, minus 10 minus 14 is a minus 24 over 6, which is minus 4. So again, we get the same answer. That's one thing I like about math. The truth is the truth. You plug in the values of 2/3 or -4, and it will make our original equation true. So those are some 3 examples, and ideally you choose the best method. When we're asking just solve an equation, you could choose any method that you want. And there's some strategies in choosing maybe the most efficient way. So if it could be factored, that's where I would like to go. That's the avenue I would do, is factoring. Next step might be if I could easily complete the square on an equation, I may take that step because this fundamentally quadratic formula is completing the square. If that's not done easily, then that's my last resort, would be the quadratic formula. So let's go talk about the discriminant for a little bit. So in the quadratic formula, the quantity under the square root sign, in other words, the value of b squared minus 4ac, is called the discriminant. And the discriminant tells us, or the value discriminant tells us how many solutions there are. The reason is that when d is greater than 0, then we have 2 distinct real roots with 2 x-intercepts. Because when you square root a positive number, we're always going to get 2 answers, a positive answer and a negative answer. However, when the discriminant is 0, well, the square root of 0 is just 0. So really, when we look at the quadratic formula, this disappears. So the solution is really minus b over 2a. That sounds kind of familiar. That came back from partial factoring. Really the x-coordinate of the vertex. But there's only be one intercept. So how we could describe this is there's 2 equal and identical real roots. Okay, not really important for this year, but once we get into grade 12 and you talk about non-real roots, we have to recognize that in this case there are actually 2 roots. They're just the same. Okay, and that's why there's only one x-intercept, and there is one answer that's 2 answers are equal. We could phrase it that way. Finally, when the discriminant is negative, there are no new roots, no real 0 roots, and therefore there's no x-intercepts, because we can't take a square root of a negative number, at least not yet. So here is a question of determining the number of solutions without solving. So we really want to figure out the value of the discriminant. So b squared minus 4ac is equal to, well, this is going to be 1. So a is 1, b is 1, c is minus 1. So b squared minus 4, a is 1, and c is a minus 1, so I need to be careful. So I got 1 plus 4, which is 5, so therefore there's going to be 2 solutions, since the discriminant is positive. Missing something here, that should be equal to 0. So here a is 5, b is 3, c is 2. So it's not written in standard form, so just recognizing that there's the x squared, there's the x, and there's the constant. So here b squared minus 4ac is equal to 3 squared minus 4. A is 5 and c is 2, and I can almost see right away 9 minus 20 plus times 2 is 40, which is negative 31. So in this case there's going to be no solutions. Last example, gotta again make sure that one side is equal to 0. So we're going to get 3x squared minus 6x plus 3 is equal to 0. One thing I noticed right away, we're going to factor out a 3, but we'll just leave it as is. So here a is going to be 3, b is minus 6, and c is 3. So b squared minus 4ac is equal to minus 6 squared minus 4 times a, which is 3, times c, which is 3. So here we get 36, because negative 6 squared is 36, minus 4 times 3 times 3, so 4 times 9 is 36, which is 0, and therefore there's going to be one solution. Big surprise. One example of each. Finally, last, we're just going to end off with a word problem. And really, we need to just find the equation to a word problem. Big hint, every equation probably going to determine or derive from this unit is going to be quadratic. So here are two positive integers who have a ratio of 1 to 3. That means one number is 3 times larger than the other. If their sum is added to their product, the result is 224. Well, let x be the smaller number, and therefore 3x is the larger number. So how do I get that? Well, it's the 1 to 3 ratio. So these two numbers have to be related or connected somehow. So if they're sum, so here we go, x plus 3x, that's the sum. So here we top of the equation. So remember lest from grade 9. There's the equation. If their sum is added to their product, so the product is x times 3x is 224. So there's our equation. Now we just have to go off and solve it. So we need to expand this. So this is really x plus 3x plus 3x squared. So we really don't need the other bracket there. So this is equal to 224. So really 3x squared plus 4x and minus 244 is equal to 0. So my guess is this is going to be factorable because the answer is an integer. So that's a big hint that this is going to be factorable. So what's the product sum integer? Well, 3 times 244. That's 732. So it's going to be negative 732. The sum is going to be a positive 4. And, oh wait, hold on. It's 3 times 224, not 244. That's a 672. Sorry, my bad. 672. And the two numbers that multiply to 672 and have a difference of 4 is 28 and 24. And because we have a positive 4, so this is a positive 28. So let's decompose that to be 3x squared plus 28x minus 24x minus 244 is equal to 0. So in this case, the 328, at best I could do is just factor out an 8. Sorry, an x. So we get 3x plus 28. And with 244, I'm guessing you factor out an 8. What am I doing? So we're going to let x be the smaller number, and 3x is the larger number. And how do I get that? Is this 1 to 3 ratio, so the numbers have to be related in some ways. So what's my equation going to be? Well, it says the sum, so x plus 3x, is added to the product, so x times 3x, that's going to be 224. So here we get 4x plus 3x squared is equal to 224. And my guess is that this is going to be factorable. In fact, I know it's going to be factorable because the answer is an integer. So if it's going to be an integer, one of the zeros must be an integer. So here we're going to subtract 224 from both sides. So we get 3x squared plus 4x minus 224 is equal to 0. So the product's integer. So the product, when we take 3 times 224 is 672. In this case, a negative 672. The sum is going to be 4. And going through and trying various combinations, eventually I discovered that the two factors are 28 and 24. That's the two that have a difference of 4. And since the sum is positive, this is a positive 28 and a negative 24. So here we're going to decompose. And I'm going to just do this up here. Decompose the 3x squared, sorry, the 4x to be a plus 28x minus 24x minus 224 is equal to 0. So common factor that out. For that pair, the best I could do is an x, so I'm left with x plus 28. And then my guess is I could factor out 8 here. So 224 divided by 8. It's 28. So here again, negative 8 is going to be x plus 28. It's equal to 0. Oh, I forgot the 3 here. Sorry, my bad. So my factors are now got the 3 over there as well. So here we're going to get x minus 8 is one of my factors, and 3x plus 28 is the other factor. So solving for both, x minus 8 is equal to 0, or 3x plus 28 is equal to 0. Well, in this case, x is equal to 8. And the other solution I have is going to be 3x is equal to minus 28. So 3x is equal to negative 28 over 3. So I should have two solutions, but since I said that, or this question says that they're integers, x equals 8 is the answer. Well, how can we check? So the one thing I like about these word problems is that we could check. Maybe do a check over here. Well, that means 3x is 24, x is 8. So the sum, so it's going to be 24 plus 8 is 32, plus 3 times, 3 times, not 3, plus 8 times 24, well, 32, 8 times 24 is 192. Well, 32 plus 192 is going to give me 224. Which is what we wanted. So that works out. Okay, so the homework is just going to be a lot of practice solving quadratic equations. Give you 3 different methods: completing the square, factoring, or quadratic formula.